Yeah, you can start.
Okay.
Yeah, please.
Good morning, everyone. Thank you for your presence here. Uh, Today we have a special Café com Ciência with Dr. Nianzhi Jiao, and he's a Chong Kong Scholar Chair Professor at Xiamen University. He's a member of Chinese Academy of Science, the World Academy of Science for Developing Countries, and the American Academy of Microbiology of the United States. Dr. Jiao is the chair of the United Nations Global Ocean Negative Carbon Emissions International Science Program. He has also published more than 300 academic papers in Science and Nature series and other first-class journals, which have been cited more than 25,000 times. His current H index is 72. He found a new mechanism for carbon sequestration in the ocean, microbial carbon pump, which has been continuously listed as highly cited paper by ESI for more than a decade. The MCP was commented by science as the invisible hand behind the vast carbon reservoir. The MCP concept and related ocean negative carbon emissions approaches have been included in the IPCC assessment report of 2019 and the United Nations Intergovernmental Oceanography Commission's Ocean Carbon Report of 2021. The Global Ones program led by Dr. Jiao was approved by UNESCO and IOC as an international program of the United Nations Decade of the Oceans in 2022, which has been joined by 38 countries. So, I leave you with Professor Jiao. Thank you.
Yeah, thank you so much for the introduction. It's a great honor for me to be here to meet with all of you and hear the talk introducing the Global Lens, which is a European international program. So I didn't share my screen right? Not yet.
Not yet.
I will share the screen. To keep the signal good, I would like to turn my image. 现在是在干啥呀？没关系，出来，
还没有，只是你的名字
出来。
啊，印制还没有，现在
出来能听到吗？
可以听到。Okay, now it's on.
出来能听到？
可以。
Okay. I cannot hear you. 出来 can you hear me?
Yes.
Yes.
Oh yes. Okay. So I get started. All right. So this is the title of the program, which is called Ocean Negative Carbon Emissions, or WAS in short. To save time, I would like to use WAS for the program title, Ocean Negative Carbon Emissions. So first of all, the term emission, negative emission. So it's actually the opposite word of emission. So that means when the carbon flux of negative emission equals that of emission, they gotta reach carbon neutral. So this is a good term for anthropogenic measures to cope with the climate change or mitigation of global warming. So for carbon neutralization, in addition to the land, we have the ocean. Actually, the ocean is even a much larger carbon reservoir on the Earth. It's actually the largest carbon reservoir on the Earth. The size of the ocean carbon reservoir is about 20 times that of the land and 50 times that of the atmosphere. It played a very significant role in the regulation of climate change in the history of the Earth. But nowadays, because anthropogenic CO2 emission has already caused the negative emission into negative emission of CO2 in the ocean. So we already have multiple problems like ocean acidification. So that's what we have to keep in mind. And that's why if we want to do further negative carbon emission into the ocean, we need to do science first. So that's why I submitted a proposal to the United Nations years ago and got approved as an international Decade program in the year of 2022. And now they have more than 100 teams from 38 countries, actually 39 countries already, joined the Global West program. And their Global West is designed toward the European SDGs number 13, 14, and 17. I know you know the context of this SDGs, so spend my time to the details. I just want to focus on the missions of the Global West program. We have 5 major missions, including remote research, construction of infrastructure and facilities for the research, and also on-site demonstration, and in the demonstration in the field of the ocean. Of course, international exchange like this, as well as education and science popularization. So these are the 5 major missions of the Global West program. For the science, or for the mechanisms of recovering situation in the ocean, I would like to give you a brief introduction. I think you know these 3 well-known mechanisms for carbon sequestration in the ocean, including solubility pump, SP, carbon capture pump, CCP, as well as the biological carbon pump, BCP. So for the SP, because it can cause ocean acidification, so we just it's not really hard to control, but we're gonna make some efforts in this regard later on. For the CCP, it's called a capture pump, because when you have one more of precipitation requirements, you're gonna release equivalent amount of CO2 into the atmosphere. So that's why it's called a counter pump. And that's what we have to fix, that we have to do. And we're gonna fix this problem in this Global West program. And for the biological pump, it does not have such a kind of obvious negative consequences like CCP and SP. So it's good. But not really that good, because if you look at the carbon flux down there in the deep water, and even down to the sediment, the carbon flux there is very, very little. Like 1% in the deep water, even 0.1% of the total carbon flux in the surface, in the effective zone. So here comes the question: where is the rest of the 99%, or even more than that, are going to carbon gone? It's not easy. From carbon fixation at the beginning through photosynthesis, and then through the geochemical reactions, and then the majority is actually returned back to the atmosphere in a very short time. And that part doesn't help with the mitigation of climate change. So people think about the carbon cycle in the whole ocean, and they find there's another huge dissolved organic carbon in the water, and they are kind of refractory. So that means it can accumulate. It's a mechanism for carbon sequestration in the water column. So this is very different. This is dissolved. They are stored in the water column. They not really depends on the vertical transport of carbon down to the deep or even to the surface of barrier. Although barrier is good, but in the water it's not that bad. It's actually more dynamic. It's more useful for current purposes in terms of mitigation of climate change. even regulation of climate change in the history. So scientists know about this, but they know about this since half a century ago, but they did not know how is this carbon reservoir formed. I mean, refractory dissolved carbon or RDC in short. How it was formed is unclear, and it's called enigma in a paper by the US scientists published in Nature. So later on, about 15 years ago, we proposed the idea or a concept called microbial carbon, or MCT in short, to give a reasonable explanation about the formation of RDC carbon in the water column. Simply speaking, MCT refers to the microbial, ecological, and physiological processes that transform organic carbon from labile space to refractory space. So being refractory, they can stay in the water column for a long time. Actually, the average age of the RDC reservoir in the current ocean is about 5,000 years. So that's long enough. So this paper published in Nature Review, and the Science magazine commented MCT as an invisible hand behind the vast current reservoir. And then it's followed by many scientists all over the world in different areas, even in the terrestrial environments. For example, here, those scientists working in the terrestrial environments propose another similar concept following the MCT concept. They call it soil MCT. The citation of the soil MCT even much higher than the citation of the MCT citation, which is a consultant for the single paper. They got much higher citation now, although they came later, about 7 years later. So that means MCT is a mechanism for classification. Is there? It's existing in almost the area, all other environments, including the terrestrial, potable water, soil, and so on. So now, how can we use the concept of theory of MCT for application? I would like to give you a few paradoxes for reference. Like why productive mature waters, they are productive, but they are really, in most cases, if not all, they are sources of CO2 rather than sinks of CO2, I mean, atmospheric CO2. And MCT can give an explanation. And also for the coral reef systems, it's very, very productive and also well known because of the high biodiversity and of course fisheries resources. But if you measure the carbon flux between the air and the seawater, you'll find the coral reef systems is actually in most cases a source of CO2 rather than sink of CO2. So it's hard to explain before. But now with the MCT it can be explained. At least they lost the RDC environment, which is a kind of export of carbon outside to the outside of the carbon systems. So it's left behind. If you put it in and you click the button, you're locked. The carbon systems, if not all, maybe at least a part of them, some of them are stored or saved by sources of CO2. Similarly, in some other cases like chlorine, like soil marshes, and some others, if they include RDC MCT process again, this chlorine could be more productive, more like a sink rather than first. Of course, now blue carbon are considered sinks of CO2, but in some cases, if you measure the carbon flux between the interface of atmosphere and the seawater, some of them are actually sources rather than sinks. So if the LRBUC it become sink, back to sink again. Yeah, similar situations also in some other scenarios like aquatic culture area and also wastewater treatment plants. Now this is for sure. There wastewater treatment plants are a source of CO2 and the big source is about number 10 in other sources. So FCT application is very promising. Now I can to some time I summarize all the applications into three sorts of practice, like land ocean integrated economy, which can integrate MCP, BCP, and SP. I mean, this is the current situation mechanism related in marine environmental marine environment conditions. Of course, the series farming is also a good size for application for all of these mechanisms, BCP, CCP, MCP. And for the wastewater treatment plants, we can apply MCP, SP based on the alkalinity enhancement within the wastewater treatment plants, and then can be the water into the ocean, even into the river. It's also working. Okay, so this summarized items, but for some details, I can give a few cases. Like here in the coastal water in the estuary area, if you measure the current flux between the interface, as I mentioned, they are usually source of CO2 rather than sinks. So this is not really easy to understand, but I can explain here. So yeah, of course, if you have more nutrients, you're going to have more carbon fixed in general case. But in that case, the carbon fixed are usually labor. You know, labor carbon. They can be a kind of an incubator of bacteria. Then bacteria thrive, and then they respire the carbon into CO2 very rapidly. So ultimately, they will transform the organic carbon into CO2 and back into the atmosphere very rapidly. At least the majority. And in addition to that, we have the organic carbon discharged from the river. And even the RDUC from the river cities, if they reach to the water under different environmental conditions and different microbial community, they will be expired again because the labor RDUC is a kind of has a kind of a primary effect, and the RDUC, so-called RDUC from terrestrial sources. They are here mobilized for respiration. So that's why it's the estuary olefin source rather than sinks of CO2. And during this process, the CO2 released into the water will react with the water molecules, and then cause water acidification according to the chemical equilibrium I showed you earlier, right? So, and it also causes consumption of CO2, because hypoxia, that's not good either. So that's why the facial resources will be reduced. And of course, the carbon precipitation similar things under acidic conditions, right? They could release CO2. That's why it's called CCT evaluation. Okay, so about 15 years ago, I proposed a kind of idea to increase currency in good water by reducing fertilization of the land. This simplified explanation about the mechanisms for easier understanding by the people and also policymakers. They are listening just what I talked about just now. And you can look at the mouse cross-cutting image here. The bacteria cells under rich nutrient conditions and under deeply nutrient conditions. They're quite different, right? So here, the organic carbon store inside the cells. This is the kind of refractory, not unrefractory, but still it's not easy to be decomposed. So that's one of the visible evidence. Okay, so if environmental conditions already, if I could water already be polluted like this with eutrophication, toxic, and acidification, so we could take some measures like use some alkaline minerals like olive lime to enhance their alkalinity. So in that case, we're going to have carbonate precipitation without much CO2 release or occupancy. Go further into the ocean. You also have some problem, either anthropogenic or naturally occurring disasters like this, which is a green tide. Green tide is a kind of notorious these years. In some parts of the China cities and also some other ocean areas in the European country area. I don't know if there are some kind of events here, but it's not a specific event. It's become more and more common on the global warming scenario. Now we're going to, although people already thought about how to make good use of this kind of resource because it's not kind of crowded, but still it's not that much, or the resources are kind of limited for usage, like industrial material, like a fertilizer. And sometimes, if they're with a good quality, they can be for food. But now, we Global Wise program also propose kind of outlets for carbon substitution by dumping, series dumping process. You heard of this approach, which is not by us, but by other scientists from the virtual world. They think the successful or other series can be used for dumping. So this green tidal energy can also be used for the same purpose, but we have to be very careful about the bubbles in the biomass, something like that, etc. So what we are doing now is also based on the principles for carbon substitution in the ocean, including MCP and CCP. So this is going to be a new approach for utilization of this resource. I would rather consider the green tide as a resource not to be put in good use, but rather than simply Okay, so for since we are talking about the civics, we need to mention the civics contribution in the field by human efforts like this. You can see there's a lot of skill contribution of civics. These are in China city with Chinese people. And we can make good use of the field in addition to their civic developments. Like Asian people, Asian Chinese people make a house, have the roof of the house using their cities. But that's a symbol for sustainability. But now we need to think about some new ways, and the constitution is one of the most promising. And we also have to keep one thing in mind. Is the pollution classification down there in the civic cultivation field. I mean, even you contribute to advertising, it has a classification down there, people order settlement. And then now we propose some ideas like artificial upgrading, especially driven by clean energy, like here wind energy, solar energy, and wind energy. So you can bring up the deep water with high nutrients to the surface of the water, to the surface of the water here for the photosynthesis by the cities or even microalgae. So they can make good use of the nutrients. Of course, they also bring high DUC, but during the daytime, photosynthesis is very strong. The DIC is kind of limiting as well as the nutrients, of course. So this is a good idea. This is it's a very it's reasonable in terms of the theory. And in practice, you have to study the environmental conditions currently, case by case. And in case you got too much nutrients and kind of other rule, like a micro rule, we also have some preparing for that, like hydraulic radical, which can kill microbial cells and microalgae cells by breaking down the DNA out of the DNA of the cell. And the cell wall is still there, the cells are still intact. Then the intake cannot be released into the water, causing pollution. I mean, no much pollution. And meanwhile, there are a lot of molecular carbon produced by the surface and also by the can be good for aggregation of the cells because they are very large, right? The polysaccharides can help for the aggregation of the particles and to make a stronger, larger sinking down blocks for building. And if you also apply the CCP, I think you're not the middle C, but the CP carbon is off for precipitation of carbon dates without release of CO2 waste. And that very organic carbon as an inorganic carbon simultaneously to make your seabed cleaner than the Europeans. So that's the ideal story, which can be simplified by using the four mechanisms for constitution evolution. The hydrogen pump, carbon is pump, microbial carbon pump, and the sulfuric carbon pump. These are the initials of the terms to make up B, C, and S in short. So this is a kind of synergistic efforts. We see BCMS, you could look at a dictionary which come up on internet. It could come up with this form. Words, business community management. So this is good name and also a smart approach. When we say smart, that is representative of the following words: specific, medical, achievable, realistic, and transparent. So it could be a best practice. Okay, so what I should also mention is to make use of the series for feeding of the cattle, remnants, which can emit methane. That is more severe greenhouse gases. Right? So if that works, you can make ideal cycling because they were grazing less grass and make less release of nutrients into the rivers and less impact on the coastal water. So that is a really ideal cycling. Scientists already got some data about the effectiveness of feeding the cattle with the environments, with the cities, especially the red like this, so they are more effective. So this is a good idea. Some study already showed a high percentage of reduction of methane emission by feeding the cities. Extraction is not only about this. So this should be mentioned and be considered wherever possible for application, for practice.
And another case I mentioned earlier is to make good use of the wastewater treatment plants for negative carbon emission. There's two aspects to be considered. One is the microbial processes. This is all of the water treatment plants apply the microbial force to the wastewater. So I don't need to mention much. And you could also think of gene engineering for some specific microbes for carbon sequestration. Simply speaking, produce less CO2 but more RDOC. And another more simple way you could apply this simultaneously is alkalinity enhancement by adding some olivines, like alkaline minerals like olivines, like I mentioned earlier. So in that case, because the wastewater usually with a lower pH, so the dissolving process is actually quicker. And after you make sure everything's okay, you release the effluents of the wastewater treatment plants into the natural environments, especially in the coastal water. And the treated wastewater, because they are kind of fresh water, they were floating on top of the seawater, with more chances to take up CO2 from the atmosphere because they can spread out, right? So that could make two changes. Turning the wastewater treatment plants from a source of CO2 to sink of CO2, and also from invested units to profitable units. And this idea has been accepted by the community all over the world. Some agency like Carbon to Sea has already applied this. So like this, WWTP stands for wastewater treatment plants, for AOE. They have selected this approach for negative carbon emission. Starting from this year, there are lots of applicants for that call, as far as I know. That means the idea has been accepted by the community and began to put this idea into practice in some area, not only in China, I mean, in the world, wherever possible. So you could also consider this idea here in Brazil. Then we need to develop the link for feasible practice. I mean, from theory to techniques to protocols to standard, even international standard. And I'm happy to tell you, we already got approved a working group on ocean negative carbon emission and carbon neutralization approved by ISO. ISO here stands for International Standardization Organization, which is powerful. And the first proposal for protocols already approved the year before last year. So this is a good platform for you to consider to submit your techniques if you have on hand, or we can develop together in the future collaborations. And in addition to the techniques, I also want to draw your attention to some idea and visions. See here, we call it triple real vision. That means not only the techniques, but also the issues related to law, to protocol, to ethic dimension should be considered. Now this is more than the MRV principle, which has been accepted by the community. But think about the other ways like AOE and iron fertilization. You will believe the triple real vision is necessary and even essential for application of ocean negative carbon emissions. And if you compare the applicability, you will find the one's approach is even more feasible than the other classical or typical ways like OAE, I mean ocean alkalinity enhancement, and IOF, I mean iron fertilization in the ocean. So in terms of the principles, including MRV and ethic consideration, as well as the law, like the newly established kind of law, convention, maybe convention is a better word for that new protocol on top of the landing protocol, which is very well known. And the new one is a BBNG. I believe you know of this, which has become effective this January 17th. It's about diversity, but it has lots of constraints on activities like MCDR, I mean marine CDR. Marine CDR, MCDR, carbon dioxide removal. So you must know of this. So I just want to mention this. We could have discussions if you want. So now, based on the principles and the practices and also protocols and standards, we have more and more consensus from the scientific communities all over the world. So there are more than 100 PI or teams from 39 countries have joined us. And we have set up some international hubs in the European, American, and Asia areas. So I think it's about time to stop, but I would like to mention some collaborations with some other areas. So for your reference, I will make it simple. So here, USA, for example, we have collaborations with the American Academy of Science, Engineering, and Medical Science. But we are focused on the collaboration with the American Academy of Microbiology, and which has established a kind of a strategic working group for mitigation of climate change based on the microbial consideration or perspectives. And we have published a joint paper in 8 journals simultaneously. At the same time, I mean, same paper published in different journals that also made a record because this is editorial. And we're going to do the same in the near future for the ocean negative carbon emission. And you're invited to join us in the coming June. The AAM going to have an annual meeting. ASM actually have an annual meeting. We're going to have side events and sessions there, which will take place in June. I believe some of you will participate in this annual meeting, and you're welcome to join us for our session and our panel. China may talk about this with you in details. And for European countries, we also have very close collaborations. Here is an example. We have published assessment reports on the ocean negative carbon emission based on our understanding both in scientific and ethic and the dimension of law. So that's one of the collaborative achievements. In addition, the States and the European countries, we also have the participants from the developing countries. And in this regard, we have the TWICE, which is called the World Academy of Science for developing countries. And TWICE has established the Standing Committee for Climate Change with 9 members as a representative. I'm happy to be involved. And this also created opportunities for us to collaborating with the scientists from the developing countries. That's a kind of 3 category representatives, but I may also mention some other platforms for exchange communications like this one, the World Laureates Forum, which is very influential, and also Davos for the economic aspects, considerations. Ocean Decade, of course, you know this very well, and COPs. COPs for climate change. Since 28, and we have 3 years continuous side events, and we're going to have the side events at the COP31, which will take place in Turkey. And you're welcome to join us for panel discussion, for side events, whatever we both are interested in. Also ESG from enterprises, but they also consider environmental regard and the governance regard. And this is for this is a platform for global trading service, and global civilization high-level forum. And on this one, I need to say a few more words about STI, which is the UN STI. United Nations Science, Technology, and Innovation. Sorry, this is not in English. I just put the slides together. I have not time to translate into English or Spanish. Anyway, but this is a need to mention because they have the forum open to the world. And I was invited last year, and we have a panel discussion which got lots of positive responses. And then we write a policy brief published in the platform for the TI, which is influential, got lots of impacts. And I hope this can be also referred for our collaboration. WWTP, for example, I mean the wastewater treatment plants, we have the rules, we have the standards. We need to think about how to make good use of the resources all over the world. I mean, wastewater treatment plants are everywhere in the world, but they have impacts on the environment. What we talk about is global wise solutions. So that will make two turns as I showed you. So this idea is accepted by the community. So we published the policy brief. And we also established the United Nations Consulting Committee for Marine Ecology and Sustainability. So this is also a platform we could make good use of in the future for collaboration at the international level. Finally, I would like to make a call. Science is a global language. So this is important for exchange and for collaborations. And this is also caught some attention from the scientific community as well as the young generations. Like here, I skip this. Yeah, we have 98 young scholars from 46 countries to work together and publish their once manifesto. Once here, ocean carbon emission. So this is a good start for the young generation to join us. Join the global ones. And we do have some other accesses for the young people to have training to contribute their efforts, like the ones open science conferences like this. So this is going to be an open course made available on the internet. And I hope you, scientists here can contribute, can join us, and we can together to make a difference. Okay, so I think time is up, and I'm gonna finish up. But before finish, I would like to show you some ideas for our collaboration because I'm not be able to make it in front of you. So I show you a list of possibilities like exchange of students, scholars, and do some practice in Euro coastal water, not along with those we are doing in China. And we could do the BCMS. This is the 4 mechanisms for carbon sequestration in the ocean, as I mentioned, and also WWTP. I just talked about, and some others like time series observation, and also some here like John Ri, which is actually led by Xiamen. He is on site. Other resources we could share with you. UNESCO science report, for example, you could contribute. I could take some cases from your country to put into the assessment report. This is also valuable because every 5 years we have a issue for science report by the UNESCO. I know some of you are involved in UNESCO programs, and this is also a good outlet for you to consider. And especially, you could propose UN projects under Global Wise. We could give you endorsement for you to easy or secure your application. And also, we could have joint projects supported by your country and China for sure. I got some resources if you interested in. I can introduce some details later on. Other possibilities, I think there's a lot. For example, the standard. If you have some techniques on hand related to global ones, I can, you can make good use of the platform for standardization. Okay, I think that's pretty much what I wanted to talk about. Sorry again, I could not be able to meet it on site, but online exchange is also good. So I'm now ready to take questions from the audience. So can you hear me? I'm done for now.
Yes, stop your presentation. Then we can talk.
Sorry, but I cannot hear you clearly. And when
you speak, can you please use the microphone?
Can you hear us now?
Yes.
Yes? Okay.
Lovely, but not that clear. If you get closer to the microphone.
Okay, great. Yes, we can start with questions. Maybe questions? Not yet, John. But I have one. And thanks a lot for your very wonderful presentation. You are making a lot inside the Global program.
Sorry. Sorry, but can you get closer to the...
I go close to the camera. Now, can you hear me well?
Oh, yeah, much better.
Oh, okay. Great. Thanks a lot for coming here, even not being here in present. But hopefully later will be here with us to sign our cooperation. And thanks a lot for your talk and for bringing so many relevant information to our community here. We are here a mix of students from undergraduate program, graduation program, professors, technicians. So maybe we could find ourselves in different parts of your presentation. So some parts maybe were difficult for us to follow, but other parts I think especially our students could find themselves there. So I think like your last slides were really important to us, especially for our upcoming cooperation. So maybe you could expand a little bit more on this part, how we Brazilians from the University of São Paulo can cooperate with you in practice. So how can we get together soon? Thank you.
Yes. Okay. Yeah, I think it's very possible because as I mentioned in the last items, I didn't explain details, but we have a course called Habitable World, which is open to actually all over the world. It's going to be translated into 3 languages, into Spanish, including Spanish. So that way we have for people to understand not only English but also your foreign language. But the contents, what I want to emphasize is the contents. It's a cover a big range from the Big Bang to the birth of the Earth and the appearance of the ocean, of course, life evolution and interaction between life and environment, and until now with the climate change issues and even the future. So we have invited more than 20 experts from all over the world to give a lecture in a series. The series means they are very well organized, not independent talks. So they are connected with each other. They are very well organized. So that is a kind of systematic knowledge skill as well. I mean, knowledge is not that so important because we have an AI. The AI what we are making efforts is to put the knowledge into practice. So that's what the students would need mostly, right? So we are now making efforts with that aim. I think scientists from your country, maybe some of you in the audience here can contribute to this course. And your students can learn from that course by practice in your country as well as visiting China and many other countries in terms of collaboration. Canada, for example, UBC is working with us in this regard. We have some school there every year. So if your students are interested in this kind of training, you can join them immediately. And also for the visit, we can make it lots easier by Global One's program in terms of for both financial support and the accessibility of the whatever you think necessary that we can provide in China. So all of your students, young scholars, and even senior scientists are welcome to visit us. Once you're in China, you're supported financially. I cannot promise the outside China activities, but I can promise the activities being supported by the global ones inside China. So two sides bilateral exchanges is no problem at all within the framework of global ones.
Thanks a lot, Nianzhi. Yeah. Thanks a lot for your answer. And this is a very important aspect you have just mentioned about the exchange opportunities, because we can see here at our institute that we have many students get more and more interested in going to China. Right now, I think we have 3 students in different parts of China at different institutes of oceanography. So they are undergrads and graduate students. One of them is doing 1 year of her PhD in China. So I think we are our community is getting more and more interested in learning from you and having this experience. And hopefully we can welcome more Chinese people here at USP. We don't see many right now, but I think we have a great potential for that, especially when you come back and you talk them that we have this USP China Center and many investments in this relationship between our countries. So I think it's an important message when you come back home. And Chuanglong was here close to me showing a picture from our system called Science on a Sphere, which is placed in our museum. We have a small museum here at our institute, and there is this special pedagogic tool where we can project many videos from NOAA, from the NOAA system, and then we can give classes and explain about the currents and show the deep sea ecosystems. We can the children come here from schools to visit us and to have an idea about how the ocean works. So we have this system that may connect what your education tools are being developed right now. So maybe it's also an important link we can have for education and outreach initiatives. And we have many other examples here from oceanography that we have been developed with a lot of success to implement the ocean literacy and to match some important goals from the UN Decade as well. So I think we have this connection. And just to finish my talk, maybe we can talk again later about this. We were very impressed yesterday at the USP China Center when we were talking with the main coordinator of the space of the program, that we found already many projects that could potentially be under the umbrella of Global Ones from our institution and also from other units we have here, from agriculture, geosciences, engineering, atmosphere and atmosphere sciences, atmosphere ocean sciences. So I think we have many more to talk, and a lot to come for our partnership that will be officially signed today. Okay?
Yeah, that's great. Yes. Yeah. Oh, sounds good. Well, what I may emphasize a little bit is the joint projects. I believe you have some projects already going on here. And I think if you want, if needed, you could propose two sorts of projects. One to the UN, I mean United Nations, under the umbrella of the OS, and that will be approved easily because of the global OS environment. But that's sort of for the international program. Another is a domestic one. If you propose some ideas related to global OS, you can also get funding by funding agency in your country, and also with the assistance of a company relationship with the Chinese ones. We are now have the most, I mean, the Ministry of Science and Technology most umbrella. I have the access for you to use these resources. I mean, being supported by the Youth of China, that kind of support to the collaborators like you here. If that is the case, I really can support you to get similar projects in your country, because we have the most, I mean, Ministry of Science and Technology in China to support similar or to be simply called collaborative projects in the two sides, from the two sides. Just like what been there for many years of NSF and NSFC. So because you know about this, right? NSF, the National Natural Science Foundation of America, they have the resources. In China, we have NSFC, similar mechanism to support scientific research projects in both countries. And now we have the most mechanism for your country and our country. This is very fresh, very new news. But I know because we have the global wide supervision by the most from the central government of China.
Okay, very good.
Okay.
Questions or comments? We can finish the session. So thank you very much for coming, even online, to give your lecture to our community.
Thank you.
And we can meet you later here at the USP. Thanks a lot.
Yeah.
Thanks a lot, Nianzhi.
Hopefully I will meet you in person this summer. I try my best.
Great. Fingers crossed.
Yeah. Thank you.
Okay, Nianzhi, see you later this afternoon, hopefully.